Okay, so this is the recording video for this problem. So a polynomial has um three positive integer roots, and the polynomial is x cubed minus ax squared, and then plus bx minus 2010. And we want to find the smallest possible value of a. So Vieta's formula it gives you like the product, the sum, and the alternating sum for cubic polynomials. So the product would be um, the constant. So it would be the negative constant, and the negative constant is negative of the constant, which is negative of negative 2010 is 2010, which means the roots um, are the product of them is 2010, and 2010 is 2 times 5, 2 times 3 times 5 times 67. And um, so, well, you can kind of like guess it from here, but the sum of, I mean, well, if you go from 567 kind of has to be 67, because that's kind of like how it is. And um well, okay, anyways, so we want to find the smallest possible value of a. So uh the sum of all the roots is negative of negative a, which is a. So in other words, the sum of the roots, we'll call the roots r, s, and t. So r times s times t is 2010, and r plus s plus t is what we want to find. And so to minimize the sum, you want to put like the closer ones together, and like um pretty much you could kind of like test which one is better between like these three cases. So you can have 6, 15, or 10, and 6 is the smallest. So the roots R, S, and T, they're like 5, 6, and 67. And so that's the smallest, and you would get 5 plus 6 is 11 plus 67. The answer would, for the smallest would, of A would be the sum of all of them, which is 78.